So let's talk about adding fractions. So the idea here is if you have a fraction, what is a fraction? A fraction is only a division problem, right? So if I took the candy bar, the one whole candy bar, and I divide it evenly with 12 people, each of us get 1/12, right? 1/12. Because if I have 1 divided by 12, that's the same thing as 1/12, right? If I cut something into equal pieces. So now, if I were to say, okay, 1/12 plus 5/12, how many 12ths would I have? 6/12. So for adding fractions, the rule for adding fractions is we add the numerators if the denominators are the same. Okay? If the denominator is the same, then you keep the denominator the same, because we are just saying, well, if I have 1/12 and then I have 1, 2, 3, 4, 5/12, here's 5/12 right here, and here's 1/12. And if I add those together, you can see I have 6/12. Now, whenever we have a fraction, once we are done adding, we're going to want to reduce that. And does anybody know what 6/12 would reduce down to? 1/2. And you can actually see that if you line up the 1/2, 6/12 is equivalent to 1/2. And that's because if we didn't even see the fraction pieces, we could say, well, how did you know that this was going to reduce down to 1/2? 6 is half of 12, good. And then their greatest common factor is 6. So if we divide by 6/6, we divide the numerator and the denominator by the same thing. We're really dividing by 1/2, which is how we're reducing the fraction. And we just proved by visually seeing the pieces that they are the same size, right? Everybody's on board with this? So the trick here is, what if the denominators were not the same? So let's look at one of my favorite examples, which is 1/2 and 1/3. So I'm going to move these pieces down. I'm just going to slide this right up. And we're going to see that we have 1/2 here and we have 1/3. Why can I not add 1/2 and 1/3 together? Yeah, and you can see that the sizes of the pieces are totally different. If I cut the same candy bar in half, that's a different size piece than if I cut the same candy bar into 3 equal pieces, and they're 1/3 each. So the idea here is that we have to have the fractions be the same size. Any idea about what we can do to 1/2 and 1/3 to make them into the same size pieces? What are we going to have to do? Yeah, we can. And we can make equivalent fractions with the same denominator. So what is a number that both 2 and 3 go into? Basically, what is a multiple of 2 and 3? Multiple of 2 and 3? So if we go, yes, 6. We already knew it, but let's just break it down how we would do this. Multiples of 2 are, that's supposed to be colon, 2, 4, 6, how many more are there? 8, 10. Can I list them all? Can I list them all? Oh, they keep going. Multiples of 3 are 3, 6, 9, 12. Okay, they keep going for infinity. And so if I take the 6s, the sixths, I'm going to put the 6th in the middle actually so we can see how it's equivalent to the 1/2 and the 1/3. Okay, how many 6s, how many 6ths I should say, how many 6ths are equal to 1/2? 3/6. If I multiply by 3/3, I get 3/6, right? I'm multiplying by 1. So anytime I multiply by 1, I do not change the value, right? What am I multiplying this one by, and what is 1/3 equal to? 1/3 here is equal to 2, 6. Okay, 2, 6, and you would be multiplying by 2 over 2, also the same thing as 1. So when you multiply by 1, you don't change something's value. So now if I have, here's my 1/2 is equal to 3, 6. Here's my 1/3 is equal to 2, 6. How many 6 do I have altogether if I add these together? Yeah, I can actually stack them over the top of each other. You can see, oops, here's the 1/2, here's the 1/3, which is 3, 6, and 2, 6. If I add them together, I get 5, 6. Okay, so we have to have a common denominator. A lot of this is, do you want to hear about the common mistake that most people make with adding fractions? This is why actually adding fractions, we learn it after multiplying and dividing, because adding fractions is actually harder. You always have to have a common denominator. The most common mistake people will make is they're like, oh, I think I just want to add the numerators and add the denominators, but I want to show you why it wouldn't work. Okay, so are we ready to go on? Can I switch the page really fast? So let's just show an example of what, this is the most common mistake, and I don't want you to make it. That's why I'm going to prove to you why it doesn't work. A lot of people will just say, oh, well, if I add 1/2 plus 1/3, wouldn't that be easier just to call that 2/5? Is that right? Well, let's look at it. So again, here's 1/2. If I add 1/3 to it, I need all of that. If I line it up with 2/5, you can see they are not equivalent. Here's 2/5. 5/5 and 1/3 and halves cannot become equivalent to each other, because here would be 1/2 plus 1/3. You can see that's much bigger. So this is how we can use our fraction pieces to prove it, okay? What if I wanted to add 1/4 plus, and these are not equal, okay, 1/4 plus 1/8? What would be the common denominator that I could use between 4 and 8? So let's get out our 8ths and let's get out our 4ths, and let's try lining them up first. Okay. Oh, can I make 4ths into 8ths? Why is that? Because 4 divides evenly into 8. So here, because one of the numbers goes into the other one, we can make this into, how many 8ths are equal to 1/4? And what would we multiply by? So 2/8, you're multiplying by 2 over 2, right? And you can see that those line up. Plus 1/8, how many 8ths would that be? 2/8 plus 1/8 is 3/8. Can you see that? Using the fraction pieces. Do the fraction pieces help? You see that? Yeah? Okay, let's see if we can find another combination. So what about if I wanted to add, oh, okay, yes, an improper fraction with a proper fraction. That's a good idea. So what if I had, well, usually improper fractions start out as mixed numbers. So mixed numbers. So let's say I have 2 and 1/5 plus 1/10. So basically this means I already have two whole candy bars, but I have a fraction of a candy bar left, 1/5 of a candy bar. So what I could do is I could either change this into an improper fraction and add, or I could go, okay, 2 and 1/5 plus nothing, 0, and 1/10, and just add my fractions. How do I have to add? Let's look at 1/5 and let's look at 1/10, and let's decide what's the common denominator between these two fractions. What's the common denominator? Meaning could I make tenths into fifths, or could I make fifths into tenths? Yeah, so the common denominator, the lowest common denominator would be 10. 10 because 5 goes into 10 and 10 goes into 10. Remember, we're looking for multiples of 5 and multiples of 10. So tell me the multiples of 5. 5, 10, 15, dot, dot, dot. Multiples of 10. Multiples mean multiply. 10, 20, 30. Okay, those are the multiples. What is the smallest one that they have in common? 10. So can I make, how many tenths are equal to 1/5? 2. And that's because we multiply by 2 over 2, right? 2 tenths plus 1 tenth would be how many tenths? 3 tenths. And then how many wholes would you have? 2. I could also do it as an improper fraction. How do I make this number, how do I make a mixed number into an improper fraction? This, how do I make this mixed number, change it into an improper fraction? Okay, and then, so that's 10 plus 1 is 11 over 5 plus 1 over 10. Okay. I have to have them both have a denominator of 10. This one already has 10, but because 5 goes into 10, what can I multiply the numerator and denominator by here? 2. 2 over 2. Because we want to make the 5 into a 10. Yeah, well, we'll still multiply. 22 over 10 plus 1 over 10 is 23 over 10. Now, is that the same thing? How do you know? How do you change this back into a mixed number? Yeah, 10 into 20 2 times, right? The remainder will be 3 over 10. So you divide 10 into 23 goes 2 times. 2 times 10 is 20. Remainder 3. 3 goes over 10. So these are the mixed number and the improper. I mean, usually I kind of think it's easier when we're adding just to go ahead and add my fractions. You know what I'm saying? Either way, yeah. I mean, you should get the same answer either way if you want to do it. You can always do it improper if you'd like, versus the mixed number. Okay, you ready for one more example? Yes? It's not going to change unless we can reduce it. Okay, I'm going to show you another example, okay? You ready? All right, let's say I have, okay, I'm going to use that same 5 and 10 example. So I have 3 and 4/5, and I'm going to add 7 and 9/10. Okay? So let's look at our tenths and let's look at our fifths again. What should I do first, do you think? We have to have a what in order to add fractions? We have to have a common denominator. Now look at this fraction here. How many, this is right here, this is 4/5, right? This is 9 out of 10, 9/10. To make the 4/5 be the same size as the tenths, how many tenths is that equal to? 8. What did he do to 4/5 in order to give him 8/10? 2 over 2, right? 2 over 2 is the same thing as 1 whole. 2 times 4 is 8. 2 times 5 is 10. Can you see that they are lining up? For every fifth, I have 2/10. For every fifth, I have 2/10, right? It's equivalent. Now, if I have 9/10 and I add those together, what do I get when I add these together? 17/10. Does everybody see where he's getting the 17/10 from? 9 plus 8 is 17. So I have the same size. Once I have the same size piece, but now you probably are like, well, what should I do with the whole numbers first of all? Should I do anything with the whole numbers? Add them. Yeah. If I have 3 pizzas plus 7 pizzas, I have a total of 10 pizzas. But look at this number. Is this number strange? 10 and 17 tenths. What's going on with this? What kind of fraction is that? Improper. So really, these are addition. 10 plus an extra 17 tenths. 17 tenths is what we call improper. How do we make it into a proper fraction? Or a mixed number, I should say. Mixed number. 10 into 17, right? How many wholes essentially could I make? When I have how many tenths do I have a whole? 10 tenths. 10 tenths equals 1 whole, right? So I have 10 goes into 17 one time. What's 1 times 10? 10. If I subtract, I have 7 left over. That's 7 tenths. So 10 plus 1 and 7 tenths, because that just changed to a mixed number. If we add those together, what do we get? 7 tenths.